Now let's move to this cyclic set of orbitals. There is our set of 6 p orbitals. Each of those carbon atoms you now know is sp2 hybrid because it's contributing one of its p orbitals per atom to the cyclic pi system, so it has to be sp2 hybrid. The 6 p orbitals contribute to a set of 6 molecular orbitals. For aromatic compounds, the feature that you see here, which is that there are 2 orbitals of the same energy. I've very carefully drawn this so they're lined up on the same position on the vertical scale. Those 2 orbitals of same energy are a consequence of what happens if you mix these orbitals within a cyclic system. Now let's quickly count electrons in this process. Each of these carbons is contributing an electron to the pi system, so it's easy to count to 6. We've got 6 atoms, 1 electron per atom, so there are 6 electrons in this pi system. We have a total of 6 molecular orbitals from the 6 p orbitals. There is that pattern of 6, so the lowest 3 are filled and the highest 3 are empty. So the 3 filled ones are pi bonding orbitals and the 3 empty ones are pi star antibond. So aromatic compounds, they are cyclic pi systems and conjugated, and they're planar, they're flat. This whole concept of conjugation means that these p orbitals are overlapping. For them to overlap, they need to be lined up together. And if they're lined up together, their nodal planes are lined up together. A flat, regular, hexagonal hydrocarbon. And there are 3 filled orbitals, and for this simplest example, there are just 6 pi electrons. But in general, a guy called Huckel, a long time ago now, stated a crucially important rule to generalize aromaticity. You're not restricted to 6 electrons. This 4n plus 2 rule, which is referred to as Huckel's rule, is a simple way of counting in 4s. The rule is based on the fact that this little n here is a whole number. Think of a number 1. That's the simplest of the integers, the simplest of the whole numbers. 4 times 1 is 4, that's 4n, plus 2 is 6. So the simple classic aromatic systems correspond to 4n plus 2, where n is 1. If n is 2, the next integer in the series, if n is 2, 4 times 2 is 8, plus 2 is 10. So 10 electrons is aromatic. Aromatic compounds, very stable, and they correspond to Huckel's 4n plus 2 rule in the general case, and they are conjugated planar cyclic pi systems.